All right, so when electrons are flowing through a wire, it creates a magnetic field. If I take that wire and wrap it around itself, I've multiplied it. If I take and wrap it around itself 10 times, it's 10 times stronger. So I take my meter and I divide that by 10 or just move the decimal one spot. But what if I took that wire, flowed electrons through it, and went around and 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 around a whole bunch more times? What would I end up with? Electromagnets. Yes, I'd end up with an electromagnet. So here I have for you set up an electromagnet. Here's a coil of wire inside this plastic that's wrapped around and around and around and around and around a whole bunch of times. What's beautiful about this, if I flow electricity through it, it's 24 volts. This is a little transformer. The transformer steps it down to 24 volts. So it's a very low amount of push. So the wires have to be wrapped a few more times. As I flow electrons through it, I get an electromagnet. Is there any benefit to being able to do this?
Yeah.
Like what?
Roller coasters.
Oh yeah, you can do that with roller coasters. Yep. What else?
Maglev trains.
How about if I go to the right?
Not progressing the story.
We're leading you into the end. Anybody ever been to a wrecking yard?
Yes.
All right, so there we go. We'll start over there. Okay, so can you think of anything I can do with this technology?
Pick up a car.
Oh, I can pick up cars. And I can take them over here and release them and they fall. And I go over here and pick up a car and go over here, release it, and it falls. I can do that with electromagnets. They have a big giant coil of wire in there. They flow a electromagnetic field, throw amps through there. It's increase that magnetic field, and voila, we can pick cars up in one spot and up them somewhere else. What else can I do with this, though? What if this was a type of valve, and there was a pipe coming in and a pipe going out, right? And I pressed this, and it allowed for something to flow, and then I released this. No flow. Yeah, this is called a solenoid, and if I hook that solenoid to a valve, it turns into what's that called? A solenoid valve. Solenoid valves we use in HVAC all the time. We can use a solenoid valve to control the flow of water. I can use control the flow of glycol. I use it to control the flow of refrigerant. I can make a solenoid valve that stops the flow of refrigerant. How cool is that? I can make control the flow of oil or gasoline. I can make it control the flow of beer if I wanted. We can use it to control the flow of air. We use it to control the flow of just about anything I want to control. Solenoid valve. What about if I made this plunger, when it came up, I made it hit another switch and made another switch do something? Could I do that?
Yeah.
Yep. I can do that as well, and that's called a relay. Relay is. We'll get into those later.
Why do you want to control the flow of refrigerant? Because if you restrict it, isn't your cooling going to, refrigeration effect going to be reduced?
It's true, but let's he has a great example, great question. How do I want to control the flow of refrigerant? When temperature drops, what does pressure do? When temperature goes up, what does pressure do? Drops. Let's say I had my evaporator in, say, a walk-in freezer. Okay? What's going to be the pressure inside that walk-in freezer?
Cold.
Very low. Low pressure. The condensing unit is over here outside, and it's very warm outside. What's going to happen to the pressure of the high pressure? Okay, so there's going to be higher pressure here and lower pressure in that box. So with pressure, refrigerant also moves, right?
Yep.
So if they have a hot box over here and a chilled box over here, where do you think the refrigerants want to go to migrate to?
The other one.
The refrigerant is going to migrate out of the condenser, and all the refrigerant is going to be like, hey, everybody hang out over here. It's chilling.
At a high pressure.
And all the refrigerant is going to hang out in that evaporator. They're going to flood the entire evaporator. All the liquids will be like, yes, beach time, it's great. All the liquid is going to be inside that evaporator. The evaporator is going to be flooded with liquid refrigerant. With the oil. A lot of the oil is going to leave the compressor as well. So now the compressor starts up, and for one, it starts up without oil, and then two, as it starts pulling this way, what do you think it's pulling out of that evaporator?
Liquid.
Massive amounts of liquid, and now you get liquid over to the compressor. And that compressor tries to pump a liquid and snap. So what we can do, and we'll be talking about this in the commercial class, but I could put a solenoid valve at that walk-in freezer, and I can make it to where when I want it to shut off, that solenoid valve closes. So therefore the refrigerant cannot migrate. When the system is off, it cannot migrate. We actually use it for a control, but we're a ways before I'm ready to talk about that. But we use it in refrigerant to control refrigerant flow. Neat, huh? It's cool. You can take this solenoid valve and install it in your neighbor's yard, right? Have a little controller on your side, make that solenoid valve open and close, and you could really screw with them, right? You can put one in reverse, you can press the button and it actually closes when it energizes, pulls it closed, and you can stop the flow of water, right? Oh, I used to take a shower about this time, click. Coming outside, look at their water meter, soap everywhere. What's going on inside? Flow.
Dude, you must be the most evil neighbor so if you don't like someone. You're like, solenoid valve here.
I've never done that, but
Just one.
thought crossed my mind a time or two.
Yeah, it was just one. That's how it done.
My ex-girlfriend, she would get so mad because I'd always, everywhere we move, I'd always find where the water heater was, and the water heater always has a valve on the incoming side of the water heater. So you can always, it doesn't shut off all the water, it just shuts off the hot water. Ah! Ty, beep, 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 beep. Close the door, go sit on the couch.
Yeah.
What's up? Did you do something with the water? Did I do that? No. After the fourth or fifth time, yes, you would.
You'd be the only one to know how to do that.
I don't know why we broke up. I have no idea why she left.
It's a mystery.
It's a mystery. She was so nice too. It's a shame. So, anyways, moving on. We use this for electromagnets. We can control the flow of things. We can do a lot of really cool stuff with it. But what's interesting though is if I take this and I come through and put a coil here, a coil here, a coil here, and a coil here, and then continue the flow of electrons. And I take a magnet, and also with electricity we have direct current and alternating current. Alternating current, the flow of electrons are changing direction 60 times a second. So this one side becomes positive, negative, it changes, and especially because I put them in series, it's going to affect how electricity is flowing. So this side will be a positive, and this side will be a negative. So positive electron, positive and positive, negative, negative, what are those charges going to want to do? Like charges do what? They want to repel each other. Like charges want to repel. So what's this magnet going to want to do? It's going to want to turn the other way. It's going to want to be like this. It's going to want to be negative to positive, positive to negative. So I know you're like, wait, what? So I'm going to show you that.
Yeah, I know it's like a magnet. Put it together and then it wants to repel. How much you say it change per second?
60 times. 60. 60 times a second. Harry Potter. So, this is it's like a miniature Van de Graaff generator. There's a little motor here and a belt, and what the belt is doing is it's throwing electrons off from one side to the other. So I'm going to fill the stick with negative electrons. So the negative electrons want to repel each other. So I'm going to put this here, and since they're just going to sit here because everything's equal, so there's no movement, no flow, or nothing. Now as I energize this, make this start working, I fill it with negative electrons, and the electrons are repelling each other. So notice how those pieces are all pushing away from each other, right? So the wand is full of negative electrons, and this piece of metal cloth stuff is full of negative electrons, which is causing it to be open. And
Yeah, now you know how they do it. Yeah.
the negative electrons are repelling each other. So as I put the wand here, it's keeping it to where it's levitating
I knew you were
because of negative electrons. They say, be anything you want to be when you grow up. I wanted to be a wizard. My mom says, you can't be a wizard. Whoa, look at me now.
That's crazy.
Right? But no, seriously, it's
It will
the...
never go away though.
No, they will eventually. Here, let me show you what happens though. If I touch it against this metal, see it attract to the metal?
Yeah.
Pulled to it. So now the electrons here are balanced out to that. Everything else is equal. And it jumped back to this. But now if I put the electrons over here, I fill it with the negative electrons again. My batteries are getting low.
Yeah.
And that's why you can't be a wizard.
Yeah.
No!
Told you, Tommy!
Yeah.
There we go.
Where'd you buy that?
I don't remember. I buy stuff all the time. It's ridiculous. It was funny that at the conference they said, wow, you must have a really good budget from your school. I'm like, this is all my stuff. My school would, like I could barely talk them into buying parts. Like I could get them to get this. This school here is really cool. They do work really hard to get us what we need. But yeah, it's the electrons repelling themselves. Right? So there's all kinds of other stuff I have in the box that
As long
does.
as you don't touch them, you can do that forever.
Well, I can't touch it. Look,
You know what I mean? As long as none of that's
it's pushing away.
No, the electrons will
But if it
slowly
touches
go away.
something else, see, all electrons left, it crumples up. Now pick it up and put it back on my stick. Okay, so now if I energize it, now they're repelling again.
You know what I mean? Like, say if the battery die in that. Would,
And this, then it won't spin and it won't push them apart. But all I got to do is charge this up. This is full of negative electrons. This is full of negative electrons.
See, if the battery ran forever, yeah, it'll never touch.
But see, I shut it off now. See, I don't have to press the button at all because negative electrons, until something makes these electrons separate to where there's a difference in charge, it will forever and always
oh, for that's what I mean. Okay.
do this.
Oh, that's what I was saying.
Just trying to.
Oh, what I'm watching this whole touch game, I really.
I'm going to put it back in the box. There we go. So I got several things that do the same.
Oh, they give you like 8 of them just in case. They know how you are with your thermometer.
Just in case, I knew him.
That's all I have.
See? And then it touches back down again. You can also do it the other way. If I have this little fella here, what are you going to have your stuff all over the desk for? Can't you make some room?
Honestly, I thought this whole side was mine.
I see that. So I'm going to put this on the table, and since it's touching the table, any negative electrons it has are going to go into the table, right? So it's always going to have a different charge than this wand here. So if I get this going, see how it's pulling towards it? Pretty cool, huh? See, if I touch it, then it doesn't do nothing. Well, let it balance out completely. Right, see, now nothing's happening. But if I energize this, it's moving again. Electrons. Electricity. That's also electricity. And what the heck, we'll do one more. Do you know what these are?
Pythons?
Pie tins?
Dopest pie tins.
You want to get some more of these? I need some more of these.
Those are personal pie
That's
tins,
right now.
dude.
Hobby people.
I fill these up with negative electrons, and the negative electrons want to repel each other. So they start flying off the end. Questions?
Like 20 of us on there, would they all fly off?
That's why I want to see if I can get into where I can get some. I wanted to get 20 of them to try that. See, we're thinking.
What if they were bigger? Like, what if you found some that were a bit bigger would still do the same thing, you think?
I don't know. It's a good question. Let's try it.
Yeah.
A Coke can will work as well. Anybody have a Coke can? Nope. Okay. Ah! See if you're awake.
Can't have Marty here no more.
All right, so the negatives repel negatives, but the negatives attract positives. So what happens is it wants to do this right here. So if I hook a shaft to this,
Oh, it's an electric motor.
but because alternating current is changing direction and it's moving through this, now this turns into negative, and then this turns into positive. So what do you think it's going to want to do now? That's right, we're going to want to turn to be like this. And then since it's alternating current, changing directions, this turns into negative, and then this turns into positive. So what do you think it's going to want to do now? Oh, there we go. And right, and then as that electromagnetic field is running through these coils of wire, that magnetic field is changing directions, and it's pulling that magnet around, and as it does, the shaft is rotating, and we end up with what we call an electric motor. Electric motor. They have what we call poles. These are poles. You count the number of poles, and you can know how fast the motor turns. There's two things that affect the speed of a motor. Well, three things, one slip. But the number of poles and the hertz of frequency. The faster the hertz are, the faster it's changing from positive to negative, the faster that motor will turn. The fewer the hertz, the slower the motor will turn. So hertz, what's that? Hertz is positive, negative, positive, negative, positive, negative. So you have a baseline. Positive, negative, positive, negative, positive. Changing directions 60 times a second. In the US, we have 60 hertz. Their frequency is 60. So frequency in hertz in the US is 60. Hz for hertz or frequency. In the US, what do you think it is? 60. What do you think it is in Europe?
60.
50. Yes, 50.
Yeah, so mine is ridiculous.
In Europe, it turns the electricity changes direction at a slower rate. So what do you think that does to a motor? If you have a motor here in America and you take this motor over to Europe, what do you think is going to be happening to that motor? It's going to run slower. Run slower. The light bulbs. Are these light bulbs on?
Yes.
Actually, they're on and off 60 times a second. Electricity is changing directions. The light bulb is actually flashing, but it's flashing 60 times a second, and your eyes are so slow that they don't even see it. In Europe, you have a better chance because it's only flashing 50 times a second.
That's why when you watch TV, like on race cars that have LED lights, they blink slow.
That's right, because the camera is recording only so many cycles at a time, and you're seeing that flash. Also, have you guys seen the YouTube video of the bird that doesn't flap its wings?
Yeah.
One guy did, out of all you guys. It was a viral video. How could you miss
Why
it?
did you put it up on the thing?
You know why I saw it? Because somebody gave me the bird. That's why. But there's a YouTube video of a guy has a security camera, and this bird's like, his wings are like this. He's like,
Yeah.
He never flaps his wings. They're just like this the whole time. What's happening is the camera is recording so many frames per second. It's taking basically a picture every so many frames per second. So the bird is flapping faster than the camera's taking a picture. So the bird's like this. He flaps his wings down. His wings come back up. Tap, takes a picture. Takes a picture. So all you're seeing is this. It's like, what is this bird doing? His wings are up here. It's great. It's cool. But it has to do with frequency. The frequency of the hertz that camera can take a picture, the frequency of the bird flapping his wings work together, and you can see it. Look it up sometime. Don't take my word for it. It's kind of cool. So it's the frequency. So the lights in Europe are going to actually flash less often than the lights here. Cool, huh?
Is there any real reason
Same thing with appliance that they make over there, it doesn't work over here or something.
Well, that's a voltage difference too. But in the old days, if you had a movie, and I bought a movie from Europe and wanted to bring that movie here, it wouldn't work because there, and I put it in here, the VCR, the motor here would be turning faster, and it'd be moving the tape through faster, and everything would be in fast forward. It was going through everything.
What?
You take an American movie and put it over in Europe, and it's slow motion.
I wish I was rich enough to try that.
If you had well, who has VCRs now? How are you going to find a VCR tape from Europe nowadays?
You're gonna be rich.
The VCRs still work because they didn't work half the time when they were new back then. In the 80s, you couldn't probably find one that worked. There's always something. But it had to do with that motor. But now we use our CDs. Isn't a problem because on CDs, they use a DC motor in most of them. So the motor is irrelevant to the frequency. It makes its own control, so you don't have to worry about it now. Same thing with DVDs. And then digital music, and digital stuff doesn't matter either because it's all digital, so there's nothing to turn the motor. All right, so now let's talk about this. A motor that has, what's it going to turn faster? A motor with 8 poles on it or a motor with 2 poles on it?
8 poles.
Everybody agree? Okay, cool. Let's go do this little project. Let's go to the hallway real quick.
To the hallway.
We're gonna need that. We're gonna need that chair.
Bring the chair.
Bring the chair.
Oh, I know where they want it. About a handful of people turn it, and then only 2 people turn it.
Yeah. Which one's spinning faster?
All right. So I'm gonna need to get 7 people. So I'm gonna be one of the people all around this chair.
No, that way it doesn't fall. It doesn't lean back when you slide the handle over.
Oh, you gotta sit on the chair.
Yeah, you little, you gotta sit.
Oh, I do need 8 people because one person does have to sit in the chair.
We all gonna be spinning this.
Oh, geez.
You green? Come on, who else?
That'd be an oxygen atom.
There's 3, 4.
Oh, that's what you're thinking. All right. So we got 1, 2. You sit here. 3, 4. Right. 5. You come over here. 6. All right. You're gonna be here. 7. One more person right here.
Alright, let's do it.
Oh, geez.
Okay, so now the frequency needs to be the same. What I'm going to do is I'm going to pass the chair off to you. You're going to then take and pass the chair to him. You take. Now everybody has to do that same thing. If we pass somebody, say we passed him, it was going too fast. We're getting too fast. So we have to go. The idea is I pass it to you. You pass it to you. You pass it to you. You pass it to you. You. Right, so get a little bit fast over here. After you pass it, hold it, stop. Okay, right, hold it, next person. Right. Just but keep it. Okay, now we're doing better. Okay, boom. So everybody has to have a push on the chair. Right? So this is an 8-pole motor. Pull, 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 pull. Right? See?
Changing it.
Yeah. All right. So see how that's working? That's an 8-pole motor.
Yeah.
Cool. So we get an idea what's going on?
Yeah.
All right, good. Now, 2 poles go away. Just 2. Not okay. So now everybody kind of center back. So we got 1, 2, 3, 4. Okay, a little bit equal distance. You.
This way.
Okay. All right, here we go again.
This is gonna get faster, isn't it?
All right, a little bit faster, isn't it? Not a big difference, but a little bit faster.
Wait till you get
Right?
Oh no.
Okay, so guys, 2 more people drop out.
Drop out.
All right.
All right, so you're there. You're here. All right, so I'm going to pass it to you. Pass it, right? So this is a 4-pole motor, right?
Yeah. Now I'm getting dizzy.
Okay, so let's drop out 2 more. All right, 2-pole motor. Ready? For you. Right, so 2-pole motor. Now, which one's going to turn faster, a 2-pole motor or an 8-pole
You
motor?
said when you count the poles, the more poles, the stronger it is.
Am I done?
I didn't say that. The wraps of wire.
Oh.
But there's wraps of wire that make a pole, and then there's going to be wraps of wire that make a pole. So the more number of poles, the slower it will turn, and the fewer number of poles, the faster it's going to turn. Does that make sense?
So what's the benefit of having more poles? Is it just
I want it to turn slower.
And what's the benefit of going slower?
Well, what if I have a ceiling fan?
Oh,
Regulate the speed.
okay.
We don't want that ceiling fan going just nonstop flying up the wall. It's going to be a problem, right? What about this turntable over here in this microwave? Do you want that turning as fast as possible?
No.
Probably not. Probably not. Although,
You might actually.
gives me an idea, but
Oh, no.
no, we want it to run nice and slow. So the number of poles is going to make a difference. But something else is the frequency of it. So frequency is how fast the electromagnetic field is changing directions. So if we had 8 people here and our frequency was fast and we could all do it faster, we'd be going faster. That'd be American. Or if we had everybody a little bit slower doing that same thing. So frequency is going to change the speed of that motor. Also, the number of poles is going to affect that motor. Now,
The power of the motor?
yes, can. Not well.
The
No,
amount
not
of
really.
electricity you put into it is what really...
Power is going to be the number of windings we use on each side. So if we have more windings there and more windings here, we can be a more powerful motor. And there's several other things we get into. We're not ready to go there. So I'm just giving you guys a base to get your understanding about electricity. And we call this an inductive load. Anytime we use an electromagnet, it's an inductive load. And what was I going to say? Poles back and forth. Oh, so in the U.S., though, we also have what we call frequency drives. When we get big commercial equipment, these motors are very, very expensive. So what we'll do is we'll have a motor that has a set number of poles that we can't change. But I want to be able to slow that motor down or speed that motor up. So what we do is that sine wave, the positive, negative, what we call frequency drives, so I can make it to where it changes from positive, negative, more frequent. More cycles per second, positive, negative, positive, negative, positive, negative. And I can make it to where that motor will move faster. And I can also slow down the frequency. I can change from positive to negative in a slower frequency. As it's changing between positive, negative to a slower frequency, the motor will turn slower. So in commercial, we use frequency drives a lot to slow down a motor, or to speed that motor up, make it turn a whole lot faster than it normally did, so we can have more hertz, more frequency, make that motor pump more, whatever we need to do with it, make it faster. Frequency drive, changing the frequency of how fast it's changing. Any questions? So there's only 2 ways, other than slip, there's only 2 ways to control the speed of a motor, which is the number of poles and the frequency. Okay, so far so good? Okay.